Welcome everyone to AURI Connect's Webinar Wednesday, part of AURI Connect's monthly online series featuring updates on the work that AURI is doing to foster long-term economic benefit for Minnesota through value-added agricultural products. I'm Dan Skogan, the AURI Director of Government and Industry Relations, and your host on Webinar Wednesdays. The AURI Connects program is hosted by the Agricultural Utilization Research Institute in Minnesota. This program aims to actively engage all participants in the food and ag industry to improve competitiveness of producers, businesses, and entrepreneurs through ongoing purposeful connection of resources and partners along the value chain and increase knowledge of opportunities, technologies, and trends. Please remember this event is being recorded and archived. It can be found at auri.org. Remember that you will be muted during our presentations, but you can send us your written questions through the Q&A portal on your screen. Supplemental nutrients are a critical component for food crop production in the U.S. and around the world. The rising costs of natural gas combined with increased production costs to source essential materials that are often in short supply make it imperative to focus on recycling essential nutrients from agricultural and miscellaneous waste streams for fertilizer use in crop production. Additionally, there is a need to address improved nutrient utilization in all production systems. So today we will discuss the nutrient recycling for crop production, highlighting the importance of local nutrient recycling and current examples of nutrient-rich byproduct streams. Joining us for today's webinar, we'll begin with an overview of the industry with Dr. Luca Zullo, Director of Science and Technology at AURI. Dr. Zullo started his career at Shell Research in the Netherlands, where he was involved in designing novel oil and petrochemical processes, focusing on process modeling, control, and integration. He continued this work in Minneapolis for Cray Research and Silicon Graphics. Later at Cargill, he worked in corporate R&D on novel agricultural commodity transformation processes. He has also worked with several early-stage companies leading or supporting the transition to commercialization from early-stage R&D. Then we will hear from AURI's senior scientist in co-product development, Al Daring. Al is in charge of managing client projects and the co-product pilot plant, collecting and reporting on data related to applied research and product development, and presenting AURI's project initiatives at industry conferences and tours. Prior to joining AURI, Daring was affiliated with the DeKalb Genetic Corporation and Farmland Industries Incorporated. Working as a research technician on activities that included genetic crossing and field plot research, he will focus projects at AURI that have focused on nutrient recovery and recycling. And we will conclude our webinar today with comments from a couple of panelists, Emma Larson and Tracy Hodel from the City of St. Cloud. Tracy has been with the City of St. Cloud for over 21 years, and currently is a public service director and provides leadership and oversight for the public utility, public works, and engineering departments for the city. She also holds a Class A water and Class A wastewater operator license with the Minnesota Pollution Control Agency and the Minnesota Department of Health. Joining Tracy will be Emma Larson. Emma has been with the City of St. Cloud for 13 years and has worked across the public utility departments, starting her career in wastewater pretreatment and biosolids. She currently is the Assistant Public Utilities Director and oversees the drinking water, wastewater, stormwater, and hydroelectric divisions. They both have firsthand experience on what is working in St. Cloud. So let's start and have Luca Zullo start the conversation today. Dr. Zullo, welcome to Webinar Wednesday.
Thank you everyone for attending, and thank you, Dan, for the introduction. Today's topic, I think, is timely since the upheaval we see in the fertilizer market. Looking at the list of participants, I think most of you are very familiar, so I will not steal too much time to our key speakers to give an introduction. But let me say a couple of comments. Obviously, we all know that nutrients are important to grow plants, in particularly NPK, and we have plenty of studies where that show that without the addition of synthetic nutrients, we are the yield of critical crops, especially cereals, will be severely hampered. And so seriously, we can't avoid this. On the other hand, when you look at the fertilizer industry, which has been extraordinarily successful in fueling the green revolution and feeding the world, is really based on non-renewable resources. Obviously, natural gas is a big component of making ammonia. Ammonia is at the basis of every single fertilizer, with the exception of potash. But potash itself is mined, and then phosphate rocks come also from mines. And when you look at these operations, those are very large strip mining operations. And while global phosphorus reserves are very large, and so we're not going to run out of phosphorus, they become increasingly more expensive to recover. And if you look at those diagrams, you already seen that there is a decrease in the production in certain areas of the world. Now, the United States is actually the third largest producer of phosphate rock in the world, but is also a large importer. So we're not self-sufficient, and we import a lot of the phosphorus from Morocco. Incidentally, another large exporter of phosphorus is Russia, and today that is one of the reasons also why there is upheaval in the market. Now, I'm not going to enter into this slide in detail, but I want to focus on this. The phosphorus that is not being used and uptaken by the plant, ultimately we have runoff and erosion, and that goes in the environment and creates other problems. And when you look at the share of global excess phosphorus from croplands, you see that some countries have a larger share of phosphorus that is actually not used, that appears not used. However, this slide is a bit misleading in that, when you look, for instance, at what appears a relatively large waste of phosphorus in the United States, one might think that our farmers are not efficient. Actually, they are very efficient. The question is what happened to the phosphorus after used by the plant. So, for instance, take a corn, and this is a thematic for what we're going to discuss today. Corn is used phosphorus fertilizer. The phosphorus goes into the corn, and now we go in the ethanol plant. The phosphorus remains with the DDGS, but only one part of that phosphorus is actually bioavailable and necessary for the animal, for the metabolism of the animal who eats that was fed that co-products. The rest is dispersed in the environment. Hence, a lot of work is done to try to recover that phosphorus from manure. However, and obviously, when you look in the context of these dramatic price changes, you see that today we are really it becomes also a serious economic impact. Ammonia has increased more than 100% in price since a year ago, and the same for other fertilizers. So you can really tell that today is not only recovering nutrients, is not only an ecological imperative, but also an economic one. And when recently at the URI we started looking at phosphorus and potassium and nitrogen, and the whole industry of fertilizer, we identify various elements in which we could operate to look at, say, dulling the impact of these changes in the fertilizer industry. And nutrient sustainability, recovery, and recycle is one of them. The other, the slides are going to be available, is more for future discussion. And going back to the previous slides, so the idea, and Alan will address that, is that, well, today, as I said, rather than feeding phosphorus that the animal will not metabolize and then goes in the manure, and then we have to go try to recover for these distributed sources. The idea would be can we recover it before we feed it to the animal, and now do it in a much more concentrated stream, and in the process adding value to already existing industrial operations. And with this, this is a good segue to Alan, which will talk about the work that we have started in identifying opportunity for nutrient recovery in the ethanol industry.
Thank you, Luca and Dan. Pleasure to be here today. And And this is a chance to share some of the work AURI has done in the past years, focusing on nutrient recovery. So there's many areas which I'll share, but I'll primarily touch on two just because of time. You know, and Luca addressed a lot of these in his opening statement, but the purpose of this is the world demand for fertilizer, along with increasing energy prices, are driving up fertilizer values for grain production. Macronutrients for crop production, such as nitrogen, phosphorus, potassium, are not endless sources. Like Lucas said, they're plentiful, but they're becoming more and more expensive to, number one, secure or mine, and then the transportation costs that comes along with them, which is a key thing to some of the discussion I'm going to be talking about today. And the third thing is recovering and recycling of these major nutrients has a direct impact on fertilizer carbon cycle. So even though we're talking about recycling, in the back of your mind, it's always nice to be thinking, how is that affecting the carbon cycle for either growing corn, growing wheat, whatever production system you're involved in. And it can improve the utilization efficiency, specifically aiding in expanding utilization area and transportation costs. Because if we can recover a lot of the nutrients locally, which we'll hear about from Emma and Tracy, yeah, it eliminates a lot of the transportation costs and additional price added to the fertilizer. So here are some examples that AURI has worked with in the past, utilizing ethanol solubles from ethanol production as a nutrient for corn production. That's the one I'm going to spend most of my time on today. This was research we conducted in 2008, and we'll elaborate on the findings. Another area we've done various work on is focusing on the value of crop residue returned to the soil. This isn't new. A lot of practices, you typically do return the stover or the leftover biomass to the soil, but in the cases where you're utilizing the corn stover or grass screenings or straws for a higher value application, and you're removing those from the soil, being aware of what is the nutrient value that you're taking out of the soil and what is the cost to that. You also have to consider what just left as far as nitrogen, phosphorus, potassium in the grain that you removed. A third thing is utilizing food processing waste as a nutrient source for crop production. And these we tend to joke about quite a bit in the pilot lab because they don't always smell the best. But when you start thinking of bean waste or edible bean processing waste, fish waste, and animal processing waste, so many of these byproducts are just loaded with nitrogen, phosphorus, potassium, and you'll see them in a lot of high-end fertilizers, natural fertilizers for home and garden applications, but we're starting to see that footprint expand, and that's all driven off of cost. So as the price of natural gases come up, along with the price of ammonia, phosphorus, potassium, some of these byproducts are very price competitive now. Nutrient recovery from wastewater streams. We've got two experts that are going to be talking about that after me, so I'll leave that. And then livestock manure as a source of NP and K, micronutrients, and organic matter. Being aware of the value. If you live in southern Minnesota, there we go. Advance into the next slide. You'll see that swine manure gets utilized quite heavily in the fall. So as I mentioned, I wanted to focus on the work we had done in 2008 with utilizing ethanol solubles for crop production, and because of the nutrient value in corn solubles. So to start, I want to describe what are solubles so everybody's aware of what we're talking about. And they are a co-product from the dry mill ethanol process. It's a flowable slurry that contains about 28% solids that can vary from plant to plant. After ethanol is produced, The mash and liquid portion are separated. The liquid portion, well, through a centrifuge, the solid portion goes one way, the liquid goes the other way. The liquid's called thin stillage. This goes through an additional evaporation process to turn it into a thick stillage, or what I refer to as solubles. And you will notice the picture I put on my right side of the screen. It gives you an idea. It is a thicker slurry, thicker than milk, but definitely flowable, and obviously temperature affects that. Now, how are these used right now? Corn solubles are reapplied to the wet mash prior to drying, and after the two come together and go through the dryer, you end up with your high energy, high value dry distiller grains with solubles that we've all heard about, the DDGS. And fun fact about dried distiller grains coming out of an ethanol plant is because they also contain concentrated proteins, residual energy. They basically have higher protein and the same energy than the corn that went into the ethanol plant. DDGS is served as a livestock protein, fiber, and energy source for ruminants. And corn solubles, AURI's had a project with this. They've also been evaluated as potential liquid beef and swine feed, where AURI collaborated with the University of Minnesota. Now, looking at the nutrient value, why are we looking at corn solubles? Ethanol production from corn grain is a growing industry in the United States. Corn to ethanol production generates a co-product called solubles or thin stillage, which we just talked about. So the solubles have been shown to contain high levels of nitrogen, phosphorus, and potassium. And here's the exciting part. So when we're talking per 1,000 gallons, that's also how you refer to nutrient value in livestock manures when they're land applied. Everything's per 1,000 gallons. So in the corn solubles, they have 68 to 72 pounds of nitrogen per 1,000 gallons. Right now, at the current fertilizer price, that pound of nitrogen is worth $1 to $1.12, depending on the form of nitrogen that you use. It has 102 pounds of P2O5 per 1,000 gallons, 73 pounds of K2O, and 8 pounds of sulfur. So these are your high value macronutrients. When you put that all together at the current price of fertilizer today, $219 of fertilizer value per 1,000 gallons. It's an incredible opportunity. Obviously, that's in the liquid form. And what we want to do is to look at how can we separate that and handle it in a dry form, which will help with logistics, storage, economics. But just in the liquid form, I'll continue. On the research that we did in 2008, the corn solubles could be land applied similar to current methods used for swine manure. And that's either load and haul or a drag line for those familiar with that process. And there's an older picture of some injection liquid manure application on the slide if you haven't seen that before. Injection of the solubles would eliminate the volatilization of the nitrogen when applied to the land. Product temperature could be a concern with polyethylene tubing used on the applicators. So the other thing I need to throw out there, in 2008, following this research, we did have producers working with ethanol plants where they were sending semi-tankers to pick up the corn solubles, bringing it out to the field, transferring it to the slurry pump and incorporating it because of the nutrient density. The one problem when you pick up these solubles out of an ethanol plant, you know, they may be coming out 120 degrees after they've sat for a while, Fahrenheit. You can see on my photo, a lot of the tubes that the manure or the slurry has to go through are polyethylene. They can get soft, so that was one of the issues. So recovering these nutrients in a solid form would improve the handling, storage, methods for this, and that's something AURI wants to continue to pursue. So to wrap up some of the corn soluble trial information and how did this material perform? We obviously collaborated with the University of Minnesota Southern Research and Outreach Center, right in Waseca. The project was actually funded by the Minnesota Corn and Research Promotion Council, which I should point out. But what the U of M did, they applied, and this is nitrogen, pounds of nitrogen per acre, 73 pounds of nitrogen per acre in one trial, 146 pounds in another, and 219 pounds in another trial. That year we had 4% greater above normal rainfall, which I should share. The grain and stover yields were greater for the urea plots at comparative levels. So what they compared the corn solubles to was urea, just to have some side-by-side growth and yield performance data. Soluble application was conducted in the spring rather than the fall, which limited the mineralization time. And I should have highlighted that. We would have definitely seen improved performance if this would have went on in the fall, which is the same time you put on most swine manure and manure applications, just to allow more time for mineralization. Because nitrogen availability that first year was only 21%. It actually improved the next year. They followed it through. But had that gone on the fall prior, that would have been much higher. And obviously the soil P&K tests were increased by the soluble treatment. And then lastly, as I've been emphasizing, data suggests that fall application would enhance performance. So that's where I'm going to leave the work we did on the corn soluble work, and AURI is going to continue to look at methods to remove the valuable nutrients into a solid form and also look at the economics there. But another project we just did for a group out of northern Minnesota, which is always good to remember, is the nutrient value of crop residue. And this, I'll go much faster, but you know, as I had mentioned, as you remove straw or take biomass off of the land, it's always important to understand what is the amount of nutrients that I'm removing. So here I used a couple examples, kerns of straw, ryegrass straw, wheat, and corn stover. It'll give you some idea of the quantity of minerals per pound on a dry matter basis. And another unique thing is straw production is directly related to moisture availability during the growing season and grass genetic potential. Crop residue, or the biomass yield, is directly related to yield in most situations. So you can predict what the corn biomass yield is going to be based on what the grain yield is. And due to soil and wind erosion on specific soil types, minimum amount of biomass that should be left on the soil is always 36%. So even though AURI is giving a presentation about, you know, if you possibly remove residue, there's a lot of data out there that suggests maintaining at least 36% of the crop residue on the soil. So when you start putting a value to those numbers, I use wheat straw as an example. So say you baled 1,000-pound bale of wheat straw for sale for bedding. What is the nutrient value of the material that you're removing? Well, you convert it to dry matter first, depending on the moisture in that straw. And in this case, the moisture was 7.6% in your 1,000-pound bale. So that leaves you with 923 pounds of dry matter. So in straw, it's 0.78% nitrogen. So 7.2 pounds of nitrogen in that bale. And at $1, that's $7.20 you're removing. Phosphorus, you're removing another 4.5 pounds at 91 cents a pound for phosphorus right now. If you're going to pay to have it replaced, so that's $4.10. Potassium, you're removing 12.6 pounds for a value of $9.32, and you're also taking off some sulfur. So all in all, just on the nutrient value alone, alone for what you've taken off for that 1,000-pound bale, you have to be sure you include an additional $21.03 just for nutrients that are going to be required for you to put back to that field. So either reducing biomass removal or understanding the value, I think, is critical on various value-added projects. Where I'm going to stop. I mean, there's many more activities going on, but looking to the future, nutrient recovery will improve our carbon footprint. If we can recycle these nutrients, keep them close to home, reduce the carbon footprint. And there's one other thing, sorry, Emma and Tracy, before I turn it over. When I was pointing out the nutrient value of the nutrient level in 1,000 gallons of corn solubles, for those of you in production agriculture there, you would have seen that with 1,000 gallons of solubles on an acre to grow corn, you had enough phosphorus and potassium to easily grow 220, 230 bushel corn and have leftover mineral for your crop, your soybean production the following year. So great opportunity there. And that's where I'll quit. And Emma and Tracy, I'll let you take it away to show how you actually bring this idea to reality.
Thanks, Alan. Thanks for the invite to present today and share a little bit about what St. Cloud's doing on the nutrient recovery side of things. So for tours, we like to show, obviously show our facility, but we do have a little virtual tour that we're going to do very quickly just to show everyone where our facility is and what it's about.
Video here is just showing where our effluent goes into the Mississippi River, and then this is going to our solids processing area where we're actually creating the fertilizer and the fertilizer byproduct. Underneath that concrete pad that you see over there is where we have our biosolids. In this field right here, we actually have ferns planted on it.
All right. So that gives you a very, very quick overview of our facility and what we're doing here. Our facility, we take about 10 million gallons a day of wastewater from City of St. Cloud and 5, soon to be 6 other surrounding cities. So we're a regional facility. And over the last 5-6 years, we've really changed our attitude and the way we do things to focus on energy and recovery of nutrients, energy, and water, which is our facility name. So starting in 2015, we did a lot of energy efficiency work, added some solar. We put in our first biogas generator in 2017, and we were able to start running our facility off our own energy. In 2018, we put in nutrient recovery and started making Class A biosolids and a struvite fertilizer component. 18-19, we added the gas storage, which enables us to optimize when we're generating electricity and when we're using solar. And then we added our second generator just now it's 2 years ago. So you can see both the engines are marked green here, and that's we'll cover a little bit. just fill in a little bit. I forget.
You're doing great.
So our Biosolids program is a huge part of what we do here. We're able to recycle Class A fertilizer on area farmland. These are our tractors and injectors. We do that ourselves. So all of the solid portion of our wastewater is digested up to a Class A, and then we further process it. And we're injecting this in the local area actually right now. Well, not while it's raining, but soon. So the Class B product is, we use a centrifuge and thicken it to about 12%. Then we use, this maybe doesn't work. What didn't last time? We use a Listec reactor, which uses shear mixing and steam to create a flowable, similar to the corn that you were just talking about, Alan, a flowable liquid at about 15% solids. That enabled us to continue to use all of our biosolids application equipment and the storage that we already had on site. So that was quite important to us.
And the farmers really liked it too, being a liquid product versus a dry product.
This should look at the slide. The Listec process, as I mentioned, that was in the building where we call Biosolids Processing. There's a lot of equipment in there, as you can see from the picture in the background. So we take our Class B biosolids, it goes through a centrifuge, and we just add steam and using mixing, and we convert it into the liquid product, which is stored at the back of the facility. The second part of our nutrient recovery comes from the struvite that we're recovering. So when we thicken our biosolids, when we use the centrifuge, we're left with a centrate that's high in phosphorus and nitrogens. So two things, we don't want to waste that by putting it back through the facility, but our headworks at the liquid side of the facility would also struggle to treat that. So we started looking into nutrient recovery. So this process sits right alongside the Listec process in the biosolids processing building. And we're able to recover these. This is our actual fertilizer. I don't know why I'm using my mouse, you can't see it. And the little white pearls. And then Ostera collects those from us in semis, and that is we used locally or regionally. So just showing all what's in this one building, which when our engineers suggested that we put this much equipment in the one building, we didn't think it was possible, but it fit. So our Ostera product, it is taken primarily up the Red River Valley for areas that are low in phosphorus, as we were talking about earlier. And there is a short-ish video.
Earth's most important elements are oxygen, hydrogen, carbon, and phosphorus. Yes, phosphorus. It's commonly found in fertilizers and is essential in the production of the food we eat. Phosphorus is necessary for all life, including people. It's vital to our growth process. For example, phosphorus is critical for maintaining strong bones and teeth. Without phosphorus, we can't produce food. Phosphorus is as essential as water or oxygen. Farmers apply fertilizers that contain phosphorus and other nutrients to grow healthy food. The phosphorus in these fertilizers has been typically obtained through mining. Phosphorus is not renewable, and mineable phosphorus takes millions of years to form. Estimates show that we have less than 90 years of mineable phosphorus left on the planet. We send phosphorus-rich water down our drains every day. The phosphorus comes from food scraps, detergents, cleaners, and excess phosphorus is flushed after we use the bathroom. What if we could recover phosphorus from what we flush every day instead of through mining? That's exactly what we're doing at the treatment facility in St. Cloud, Minnesota. St. Cloud is using an innovative process to recover phosphorus and other nutrients from wastewater. Phosphorus, ammonia, and magnesium, all from wastewater, are used to create a product called struvite. Struvite is an important part of fertilizer used by farmers. St. Cloud is able to recover more than 100 tons of struvite a year. This is enough to provide the phosphorus required to grow more than 5,000 acres of wheat. Reducing the amount of phosphorus going into our waterways can prevent other water quality problems, such as algae blooms that turn our waters green and harm fish. St. Cloud is recovering phosphorus and ensuring it is used where it's needed. The result? Helping farmers grow our food and ensure healthy waters.
So that explains better than I ever could our nutrient recovery process. So around a similar time, same projects, we were able to recover the biogas that's produced in our digesters, and then use that to run our Jenbacher engines that power the facility, and to recover the heat to save on energy for our digesters. As part of that project, we started taking local high-strength waste products. We did a tank that we had, a grid tank that we had on site that had sat empty for a number of years. And we started feeding high-strength waste into our digesters to see how much extra methane we produced. And we were able to nearly double the amount of methane biogas that we were producing. And therefore, we could justify the 2 engines that we now have on site. Anything else? Kind of already been through it. And this is our last video.
The city of St. Cloud treats wastewater for over 120,000 people in 6 cities. The facility treats over 10 million gallons of used water every day. A tremendous amount of energy is contained within the used water and is recovered and converted to electrical energy. Waste solids are heat treated using a process called anaerobic digestion. This provides great opportunities for the city of St. Cloud. In this digestion process, solids are broken down by helpful bacteria in large tanks at high temperatures. The bacteria produce a biofuel in the form of gas. This biofuel is cleaned and used in generators to create electricity that will be used on site. The excess heat produced by the generators is used to heat the digesters that create the biofuel. To generate more biofuel, St. Cloud receives byproducts from industries such as breweries and food processing facilities. St. Cloud is converting what was historically a waste into a valuable resource, reducing the cost to treat used water. Good for the environment and good for the pocketbook.
All right. So Emma showed a lot of our products that we're producing here on site. Just like Alan had mentioned, we're producing them locally. And when you're talking about carbon footprint reduction, we're creating all the energy on site to treat all of the product that we're making here. And that means clean water. That means our fertilizer product. That means our struvite product that we're producing. We have nearly 100% of our electrical demand is being produced on site through renewable energy sources, either through solar or through the biofuel generator that Emma showed with that video. And a lot of that honestly is coming from byproduct waste, similar to the ethanol byproduct waste. So we're taking product that just has an enormous amount of nutrient value to it and energy value to it, and using it again instead of wasting it, or worse yet, sending some of that product to the head of the plant where the energy demand is super high. And then we're actually increasing our carbon footprint by sending it to the head. So we're able to have the equipment on site and the process on site to do a truly recover those nutrients and the energy piece of it. This graph right here just tells you kind of how much we actually purchase from the grid itself, extremely low. If you can see for 2021, we're at 32 kilowatt hours per million gallons as far as what we purchase. So we're not purchasing, I mean, prior to the installation of the biofuel generators, I mean, all of those numbers there, not only are we energy efficient, because that's the one thing that we want to do first is reduce the actual use itself up front, but then now we're under that benchmark for most wastewater treatment facilities overall for energy use. So something we're proud of, and being able to take product from local industries and providing economic growth for them, because if they didn't have us as an option to bring their product to, they would have to build multi-million-dollar treatment facilities or haul it off to much longer distances for treatment, which is typically much higher in cost for disposal compared to the small tipping fees that we charge here at this facility. So just a couple more exciting things that we're doing. Just want to let the whole group know some of the projects that we're working on right at this moment. So we've done a lot in the last 5-6 years. And then right now we're working on a landfill organics diversion pilot project. So working with Tri-County Solid Waste and taking food waste from like schools and prisons and expired food from grocery stores, those type of things. And we're going to demo having a depackaging unit on site and converting that to energy, run it through our digesters, and then be more product for our fertilizer product as well. So that's starting up basically this week, and materials are arriving and we'll have the equipment on site. And so that's going to be exciting to find out the results on that pilot. The CSM intern project is called Climate Smart Municipalities. And so that is a program that we partner, Minnesota cities partner with cities in Germany. And so right now we have an intern from Germany. He is a graduate of an energy technology program at the University of Münster, and he's helping us out with some of our energy projects here, doing some research and some analysis for energy efficiency. We're looking into innovative technology research and other piloting, such as renewable natural gas on site. We're looking into taking advantage of applying for that LCCMR grant that's out there right now for renewable technologies at wastewater treatment facilities. So we're looking at RNG, and we're also looking at green hydrogen. We're looking at potentially converting our water that we have on site, running it through an electrolyzer, creating hydrogen fuel that could fuel our processes that we have on site, and then also an oxygen, and we need oxygen for the biological treatment process here at the facility. So it'd be really a good application, good site, and there's wastewater treatment facilities all over the world. So if something could work here, we want to be a successful demonstration project for other facilities. And then we'll continue to collaborate and work with many different universities. We're working with Water Research Foundation. We're working with 2 studies with the University of Minnesota right now, doing some evaluations of gas production, taking high strength waste, and kind of coming up with estimates of what kind of gas production we can get and the quality of that. And then what's kind of happening next, I kind of talked about a couple things here already, the RNG piece of it. We want to focus on using it on site, and then we're looking into working with our utility provider and doing some potential pipeline injection in the future. Green hydrogen, like I'd mentioned, we want to do using the hydrogen and ammonia and the RNG as an energy storage. I think it's very common that people think batteries, storage has to be a battery, and we don't. We feel like there's so many different ways to store energy and use energy. So we're looking at all the different possibilities there. As Emma showed in previous slides, we have a lot of energy production on site. We have 4 solar arrays, 2 biofuel generators. We have a gas membrane system. We have a backup diesel. We have our high strength waste tank. So there's a lot of things going on, and we'd really like to put in a microgrid, basically a management system that tells us what energy source should we be producing and using when, and because of on-peak, off-peak rates, those type of things, want to be smart with our use. And then we are working on an exciting project with Clark Energy, who are the folks that sold our biofuel generators to us, the Umbacher engines that we have on site, and looking at putting a piece of equipment on the exhaust of our biofuel generators to capture the carbon out of the exhaust and turn it into products such as cement and building products and aggregate, things like that that are usable. So it's actually a UK grant that we're working with them through. So they have a UK install and they want to have a United States install. So we're excited about that opportunity. A lot of people do ask after we do provide presentation on the things that we're doing here at the facility, and it's very common. They're saying, why is St. Cloud doing this? And there's a lot of reasons, as you can see in this slide here. For us, a lot of people think that green is expensive, going green and doing things locally and doing on-site generation, but actually our experience to date has been exceeded our expectations for energy savings and energy efficiency. So green is cheaper, and it's been like that for us. So that helps stabilize our taxes and our utility rates. We definitely have energy goals. We established them in 2015. We've already met those. So our mayor has announced new, very aggressive new goals coming forth. So that's what we'll be working on in the future, decarbonizing our heating and our electricity use, and also our transportation on a community-wide level. Obviously, we have the clean energy jobs that's being created because of all the work that we're doing on site. We have another customer. So all the food, beverage, that have byproducts, that's a new customer source for us. So it does provide us some revenue to offset any additional operational costs. And I think the big thing here too is the regional economic impact for a lot of the facilities. When we take the product, it really has reduced their operation and maintenance costs and then provided ability for them to expand their operations, add more jobs, things like that. And then ultimately, we just want to do what's best for our future and our future generations. We want to be good ancestors, right? So that's kind of an overview of, we have a lot going on at the facility, as you can tell, on the nutrient recovery side and on the energy recovery side. And we're excited to continue looking into new clean energy technologies and be a leader in this area.
Well, those were great presentations and great videos, and I appreciate Tracy and Emma, you telling the St. Cloud story. We're going to take some questions now. Just a reminder that questions can be put into our Q&A portal or your Q&A portal on your webinar, and we will take those now for the next few minutes and just try to get a few questions answered. I'm going to just start by one of your videos mentioned 6 cities that you also serve. Are those cities bringing you a waste stream via truck, or was there a pipeline system set up to transfer that, or how was that the infrastructure on that?
Yeah, so we have 5 regional cities that are connected to our system by pipe. High strength waste generally, well, it all comes by truck, but our contract cities are connected by pipe, and we're just about to add a 6th city as well.
And I just think about you bringing it out to the farmers. Are they contacting you? Are you willing to? How far from St. Cloud do you go with that product? Can farmers buy it and haul it out themselves and apply it? How does that work?
So we recycle it ourselves. We haul it and we inject it, and with city equipment and city staff. The furthest we go is about 18 miles, and that's generally only in the fall. In the spring, we're limited to closer to the facility because of road restrictions. And we have to get out before the farmers want to plant. But in terms of, do they ask for it? Yes, every year. And it's almost a little political because, farmers will know farmers, and so got this much and I only got this much. And we try to be as fair and equal as possible. But sometimes if there's a field open and the roads, we're allowed to drive on it, we'll go there.
Yeah, and sometimes our application season is so limited that we're going to target fields that are large, that are irrigated, that we can have less mileage getting the product out there in time and staff and resources. So there's a lot of criteria that goes in and consideration that goes into where we go and when we go there.
I know you mentioned, why is St. Cloud doing this? And I'm thinking, why isn't every city doing this? So is St. Cloud's system the sweet spot as far as size and location, or is this scalable to other locations if cities wanted to cooperate on a similar project?
Yeah, that's a great question. I think you hit a couple of the key things. We are in that middle size facility where we kind of are in that sweet spot where there is cost benefits to having this type of process on site. But at the same time, there's a lot of potential for other facilities, even that are slightly smaller than us, to do these type of things or work together regionally with even, building something that's both agricultural direct waste and municipal waste kind of combined and having some systems in place. And I know there's a couple of facilities in the Midwest that are kind of working towards thinking about doing that type of work, but.
We have several questions from our participants today, so let's try and run through some of those. I think this is just a question about toxicity of the product that's being put in the fields. Can my vegan dogs eat this stuff? So is it safe to handle?
Yes. So, yeah, it is safe. We get it to the level, it's called Class A. It's as per EPA standards, it's Class A fertilizer. And we're currently working with EPA on the EQ, the exceptional quality specifications. And we believe we meet it, but we have to convince EPA.
They're asking for more data,
yeah.
more data, which I'm supportive of that. The more data, the better. So
But yes, our staff don't wear PPE or like their boots and gloves, but it's safe to be around and yep.
And I think one thing that makes our program and our quality of our product even higher is that we have a very strong pre-treatment program in place. So any industry that is discharging to our treatment facility, we have very strong regulatory requirements that they need to meet before they can discharge it. So we can prevent any issues of contamination within any of our products that we produce on site. So I think that's unique too, that we work really closely with our industries in town to make sure they're not discharging anything they're not supposed to, because they have to meet certain local limit ordinance requirements.
Al, we have a three-part question, and I think I'm going to have you weigh in on here. Have you considered the carryover effect of solubles in the following crop growing season and valued it compared with urea? Are other effects like improving soil aggregate stability that may change soil fertility in terms of moisture storage and better root penetration, and other alternative use of the solubles, for example, fruits and organic crops that may pay better prices? Have you done any work or consideration of that?
Well, thanks, Dan, and those are all excellent questions, and I want to follow up with the individual that had asked it. One of the things we do the research. We don't do field trials. That's where we have to turn to collaborators like the University of Minnesota or Iowa, the surrounding campuses. But one of the things we've done, we did this with ash and biochars, is we did do some follow-up research work. And that, as I had mentioned in that presentation, this study was done in 2008. But I think we went back with the university, and I think we do have some data on that following year, because obviously you had more time to mineralize the material and it would become more available. So let me check. It was Jeff Vetch and Dr. Giles Randall. Giles is retired now, but I will follow up on that one because they're both soil scientists. I don't believe we did anything focusing on soil structure, and I know exactly what you're getting at there. What is the impact to the soil? Did it add to the basically the soil structure? You don't want your soil looking like powder or fines. And then the third thing is we haven't taken it far enough to look at it for vegetable crops yet, or those applications. Great idea, because that is a much higher value when we focus on fruits and vegetables and those applications. There we haven't done any of that work yet, but I would assume, the key thing we wanted to identify first is what is the nutrient availability. The P and K are there. They don't disappear, so you're going to get that benefit. So I will follow up with him, Dan. I got to check with the university on year 2, or if I have that in my file somewhere.
Perfect. Thanks, Al. Here's a question, and I don't know who wants to take this one. Does the Bio Fertilizer have a standard nutrient content, NPKs and magnesium?
Was that directed towards Sandfly? Not a standard, but we do analyze every cell, every year, every season of fertilizer that we take out, or biosolids that we take out. And we have all that information that is then supplied to the farmers, so they know exactly what went on their land.
Has St. Cloud done, I'm going to paraphrase this next question. Has St. Cloud done long-term economic analysis of investments versus returns on your facility for sustainability? Does this look like something that's long-term?
Absolutely. Yeah. Every time that we put in a system in place, and the nutrient recovery side is a little bit unique. We did end up getting a very large grant from the state to put this project on site, about 6.6 million to put that new technology on site for others to learn from and use. And then on the energy side, when we get our initial payback was around 12 years, but now we had a public-private partnership with a local brewery that helped pay for our second engine. And then we're continuing to add new high-strength waste providers. So actually our payback on our bio recovery, our energy recovery system is less than 4 years now. So it's pretty successful and long-term, we're in it for the long run and looking at our rebuilds on our engines and different ways to produce energy on site. But the great thing is a lot of it's rate neutral because there's some either energy savings or revenue potential with a lot of the work that we're doing.
And then the first part of their question was asking about your definition of bio fertilizer. When you say that term, what do you mean by that?
So that is our biosolids product. It is the solids portion from our wastewater treatment, and it's then digested for up to about 30 days, 25, 30 days. And then we further process it with the centrifuge and our Listec process.
Several comments here about the presentation itself and how much they liked it, and they love what the city of St. Cloud is doing and how they're leading on this. I like the fact that the facility is recovering nutrient from the waste. Is there any concern about contamination with heavy metals, pathogens, or other risks from using the biosols?
So as Tracy mentioned before, our pre-treatment program is, well, we say the best in the state, but it's pretty restrictive and pretty specific on what our industries in town can discharge. We are continually monitoring them for obviously nutrients and then metals as well. And same metals that we test our biosolids for, so we can see that the mass balance right across the facility. There's limits set by the EPA on the metal concentrations of biosolids, and we are like in the tens of percents of the ceiling concentrations of those. There is pathogens in our digesters and then our Listec process. We have actually held Listec Class A biosolids for 2 years and reanalyzed it for fecal coliforms and had no growth in it at all. So we're getting 0 out of that, which is well below the acceptable limit. The other concern that we do, and everybody has coming down the pipeline, is PFAS, and we're not sure where that's going to go and what the requirements on that are going to be. And we'll figure it out as we go and find a new technology that we can try out. And
has the city of St. Cloud considered or tried applying your nutrients through a irrigator system?
So it's a good question, because we wouldn't be able to do the solids product. It would obviously be too thick to be sending it through an irrigator, but on the effluent side, we actually could. There's a little bit of nutrient value in, and we actually use it on site for on-site irrigation for fertilizing our lawn on site. So there's a little bit of nitrogen, a little bit of phosphorus in there. We obviously want to keep it as low as possible, but that would be we actually have a project, if we extended some pipes through the facility, that we could irrigate local fields with our effluent product that has some low concentrations of extra nutrients in it.
Nan, I'm going to skip the next one and ask, are these biomass products all plant-based? They seem to be plant-based, and they're wondering just how close to marketable some of this waste product might be.
So there are wastewater treatment facilities in the country that dry their biosolids and sell it as a fertilizer pellet, sell it to the public. You know what I'm talking about? I can't remember the name right now.
Milorganite. Yeah.
Milwaukee does that.
Yeah.
And that's the Milorganite. You'll find that in, Fleet Farm or wherever. And we're of a very similar quality, whereas ours is just a liquid form. So people generally don't want a 5-gallon bucket of fertilizer.
Right.
Liquid fertilizer.
Here's a cost question about revenue. I don't know if you can answer it or not, but the St. Cloud facility, what do they receive in compensation or revenue for the nutrients that are field applied? And is this priced by the ton or in relation to what the nutrient content is?
So the two products that we have on site is the biosolids, the liquid biosolids, and then we also have the struvite. So we do sell the struvite to the manufacturer for an X amount per ton, and they do the marketing and distributing of that product. Unfortunately, on the biosolids side for us anyways, we're not charging for the biosolids product, which we have talked about potentially doing some charging, especially because now with the new LISIC process that we have for the Class A, we add potassium. And it's just have increased the value of the product significantly. So right now we apply it for free with our equipment and our staff. That's
And our fuel.
yeah, and that's the reason why Emma, like she said, we get farmers just calling us up. Can't wait to get the product.
I can see why there's a little angst at times then. Yeah. you bet.
Yes.
Are you aware? I'm going to ask, we're at 1 o'clock, but I'm going to ask 2 more questions and then I'm going to let Luca weigh in on what he's heard today and what that might mean for us going forward. But are you aware of any data on runoff from fields that have had these recycled nutrients applied? Or do you monitor that?
So there is, yes, we have very strict setbacks that the EPA set and the PCA enhance actually. And we follow those. We have GPS in our tractors. We know exactly where we're injecting this product and we know exactly where the edge of the field is. And we have the maps in GIS of where we have applied. In terms of runoff and the research, there is oodles of research online and through the EPA and through a lot of universities on leaching of biosolids product and runoff. And that's why the setbacks were developed. They were the way they were. There's restrictions on the slope of land that you can apply to and when you can apply. And as long as you're following those, it's a very safe fertilizer product.
And we'll wrap it up with explain to the audience what your high strength feedstock is and why it is high strength. And also please mention that your remaining water is clean enough to be put back in the river.
Sure, I can take that one. So our high strength waste is what we call anything that's not municipal, that's got a very high potential of energy production and nutrient recovery in it. So what we take is a lot of dairy products, we take a lot of beer waste, we take a lot of food waste, such as like a packaging facility that's making like, you know, those little packets of like barbecue sauce and applesauce and strawberry daiquiris. And so a lot of that stuff, when they're doing switch outs on their line, they'll take that excess product and they'll put it in a tank at their facility, and then they'll haul it to our facility where we create energy and nutrients and biofertilizer product from that. And yes, our water is extremely clean. And we even say that it's cleaner going into the river than what is coming into our treatment facility for drinking water, which is upstream in the northern portion of the city of St. Cloud. So we've always done a really good job with meeting our permit limitations, and that's given us the ability to expand and work in these areas.
Well, I just appreciate the presentation today. I've enjoyed it, and it gives me optimism that we can all do better in energy creation and the nutrient, I guess, creation. And Luca, like I said, I'm going to leave you with the final word here. This sounds like what we've learned or seen today is exactly what we should be doing.
Yes, correct, Dan. And a couple of comments on the work done in St. Cloud. I mean, I'm a big fan of what the team in St. Cloud has done. They show what can be done. You know, there are in Minnesota alone, I believe there are about 700 wastewater treatment plants, some smaller, some bigger. But the point, and this is truly a global solution, and they're sure that can be done by both combining both environmental and economic goals. So I think that is a template that we can do across not only the state but the nation. The other comment that I have is that, as I said, this today is not only an ecological imperative, but also an economic one. And, you know, our goal is continue working this area, raising awareness and looking and creating this opportunity. I think agriculture is efficient. We cannot get away with synthetic fertilizers. Those will always have a part in our mix as we start, however, around working on this solution. And I hope that the message we can send to that is that we can not only do better, but also we can combine being environmentally virtuous with being economically sensible, which often people think that are different goals.
Well, that concludes AURI Connect's Webinar Wednesday for today. We do want to thank our presenters and our panelists again. AURI Connect's Webinar Wednesday is presented by the Agricultural Utilization Research Institute of Minnesota. AURI's mission is to foster long-term economic benefit for Minnesota through value-added agricultural products and processes. We're interested in your feedback, so please respond when we send you our event evaluations. Remember, for more information on today's program or any of the work that AURI is involved in, you can go to auri.org.